So in this video we're going to talk about how you can use vector addition to add two forces together. So if we have, so there's going to be two types of problems when you'll be asked to do this. You'll either be asked to find the resultant force. So your resultant force is going to be equal to the addition of force A plus the addition of force B. Okay, so our resultant force in this case is unknown, while the two forces A and B are both known. The second type of problem that you'll run into is you'll be asked to find the components of a vector along a set of specific axes. So in this case, you're given a vector. So let's say you're given a force vector A. So this vector is known, which means its magnitude and direction are both known. And you'll be asked to determine what component of vector A goes about the u-axis and what component of vector A goes about the v-axis. Okay, so what was given to us is that we do know the direction of axes u and v. So these are axes with specific direction, so that we know the angle of u and v relative to our vector A. So the only thing we don't know is we don't know what is the magnitude of A of u and the magnitude of the component along the v-axis. Alright, so those are unknowns. Alright, so we'll solve for so in those types of problems you would solve for the magnitude of AU and the magnitude of AV. So sometimes you might be asked to add more than two forces together. So if you had, for example, the resultant force would be equal to F1 plus F2 plus F3, you could use it, so you could add force 1 and force 2 together. Alright, once you added those two together, you could then add it to force 3. The other option you could do is you could add force 2 and force 3 together first, and then you could add force 1 to it. So whatever makes your life easiest. Alright, so the order of vector addition does not matter, and later in the lecture we're going to develop if you have greater than 3 forces, so when you add greater than 3 forces together, we'll use a simplified method to do that. And we're going to introduce that in a few videos down the line. Okay, so when you're trying to either find the resultant force, so that's going to be, I'm going to refer to that as method or problem type A, or if you're going to be finding the components of a vector about a specific axis, so I call that problem type B. Alright, we're going to use the following analysis procedure. So you're first going to draw out the vectors. You're going to then determine what things you do not know, and you're going to solve for the unknowns using the law of sines and the law of cosines, which we introduced in the last video. So for type A problems, you're going to first, so this is when you're finding the resultant force, you're going to use the parallelogram or the triangle law to determine, or to draw out a triangle. Alright, and then for the second type, when you're trying to find the components of a vector about a specific axis, you're going to use the parallelogram law. Alright, so once you have your triangle drawn out, you're going to determine what are the known and unknown. So in the case of finding the resultant force, the unknown is going to be R, or the resultant force. So we need to figure out what is the magnitude of R, and we need to know what is the angle or the direction of R. So the second part, right, what we're looking to do is we're looking to find what is going to be the magnitude of AU and the magnitude of AV. All right, and then the final thing is once we determine what are unknowns, we can solve for the unknowns using the law of sines and the law of cosines. For the resultant force, typically we will use both the law of sines, typically to find the direction of our vector, and we'll use the law of cosines, typically to find the magnitude of our resultant force. All right, and then for the second problem where we're finding the components about a set of axes, we'll use the law of sines, in that case to determine the magnitude along the u-axis and the magnitude along the v-axis. Okay, so in the next few videos we're going to do examples of each of these types of problems, and we'll show how you can apply the law of sines and the law of cosines in order to solve for the magnitude of a resultant force and also the magnitude of the components of along the u and v axes.